Okay, everybody, so we are going to begin Chapter 7 next, and this chapter deals with probability. So I wanted to go ahead and get some of the vocab out of the way so that we are ready to start tomorrow. Probability, you've probably heard that word before. We define it to be the branch of math that deals with the chance or likelihood, let's forget how to spell likelihood of an event. So probability means how likely is something to happen, and we have lots of things that are associated with probability. You hear this all the time. When we talk about gambling, that'll be a big thing in this chapter. Gambling or card games or sports even, that deals with probability. Weather, we hear about probability of rain or the chance or likelihood of snow. We hear about that all the time when we're talking about the weather, so that refers to probability. So there's lots and lots of things that are associated with the word probability, including the word probably. Okay, when something's probably going to happen, its probability is strong that it's going to occur. So those words are related. Now, there's going to be some words that I use in this chapter, like the word experiment, so we want to know what that is. And I call it a situation or scenario that could produce various results. Okay, so we could have an experiment being tossing a coin or rolling a die. Taking a survey. So lots of possibilities when we think about experiment. It doesn't have to be like a science experiment. It could be hypothetical, like we might not actually toss a coin. We might pretend like we're going to toss a coin, but that's still considered to be an experiment. Sample space is another important word that we're going to use a lot, and it refers to the set of all possible outcomes or results of an experiment. You might not realize right now or today why the sample space is so important when it comes to probability, but it will definitely be useful to be able to talk about sample space later. For example, if I'm tossing a coin, then my sample space would be I either get a heads or tails. So I have two outcomes in my sample space. If my experiment was rolling a die, then my sample space is 1, 2, 3, 4, 5, or 6. And taking a survey, that's pretty broad. It would matter what the survey was about. But again, the possible outcomes of that survey would be your sample space. So let's see if we can identify these sample spaces. Again, it's a set, so you'll often see me use those squiggly brackets. The probability experiment consists of tossing a coin and then rolling a six-sided die. So let's think about the things that could happen. I could toss the coin and I could get heads. I'm just going to use a H for heads. And then roll the six-sided die and get a 1. Or I could toss heads and get a 2. Or I could toss heads and roll a 3. So on and so forth. Or I could start out by getting tails and then rolling a 1. Or getting tails and then rolling a 2. So on and so forth. So my sample set here consists of 12 total outcomes. So if I go down to the next experiment, consists of recording a response to a survey as agree, disagree, or no opinion, and then also the gender. So I could agree and be female. I could agree and be male. I could disagree and be female. I could disagree and be male. I could have no opinion and be female, or have no opinion and be male, which would give me 6 total outcomes. Okay, so each of these is an event that's in my sample space. These are the possibilities. And then one more. We've got an experiment that consists of recording the political party as Democratic, Republican, or other. And, Democratic, that should just be Democrat. And the gender of the respondent. So I could be a Democrat and male. I could be a Democrat and female. I could be a Republican and male, or a Republican and female. Or I could be other, which is probably independent and male, or other and female. So again, 6 total outcomes. All right, that's all we need for today. Make sure you bring this with you tomorrow.